This is the VLAN network we configured in our previous video. As you know, in a standard VLAN setup, communication is only successful between hosts within the same VLAN. If two hosts are in different VLANs, the communication fails. The reason for this is that these VLAN networks are currently configured on a layer 2 switch. Since a layer 2 switch cannot perform routing, inter-network communication is impossible. This is exactly where the concept of Inter VLAN routing comes into play. Today, we are going to explore how to achieve this using the router on a stick method. To set this up, we need a router. For this demonstration, I'll be using the 4331 router module. The core concept of the router on a stick method is to take a single physical interface on the router and create multiple logical sub-interfaces for every VLAN in our network. We then configure the default gateway for each VLAN on these sub-interfaces. Because the router is aware of all these sub-interfaces, it can receive a packet from one VLAN, process it, and route it back through the appropriate sub-interface to the destination VLAN. Let's start with the router configurations. First, move from user execution mode to privileged execution mode by typing enable. Then, enter global configuration mode by typing configure terminal. Next, we need to bring up the physical interface that connects the router to our VLAN network. Enter the interface configuration by typing interface GE 0/0/0 and then use the no shutdown command to enable it. Now, we will create logical sub-interfaces for each VLAN inside that physical interface. To create a sub-interface, type the name of the physical interface followed by a dot and then the sub-interface number. I'll start with VLAN 10. I'll type interface GI 0/0/0.10. Next, we must use the encapsulation.1q command followed by the VLAN ID 10 to tag this sub-interface to the correct VLAN. Now we can configure the IP address for the VLAN 10 default gateway. Since my subnet mask is 255.255.255.0/24 for all three VLANs, I'm using the last usable IP of each network as the gateway. For VLAN 10, that's 192.168.10.254. Finally, type no shutdown and exit. Repeat this exact process for VLAN 20 and VLAN 30. Create the sub-interfaces, tag them with the correct VLAN ID using the encapsulation command, and assign their respective default gateway IPs. Next, we need to configure the default gateways on our end devices. Click on PC-01, go to the Desktop tab, and under IP configuration, enter the gateway for VLAN 10. Now, let's open the command prompt and try to ping the gateway to check reachability. As you can see, the ICMP ping failed. Why? Because the switch port connecting the router to SW-02 has not been configured as a trunk. Since this single cable must carry data for all three VLANs, it must be a trunk port. Click on SW-02 and go to the CLI. Enter enable, then configure terminal. Access the interface connecting to the router. In this case, interface G0/1. Now, type the command switch port mode trunk. Now, let's go back to the command prompt on PC01 and ping the VLAN 10 default gateway again. There we go. The ping is successful. Now, go ahead and configure the default gateways for the remaining PCs. Now, if you try to send a PDU or run a ping between two hosts in different VLANs, you'll see that it works perfectly. Inter VLAN routing is now
active. For more high-quality Cisco lab configurations and tutorials, make sure to check out Zincops IT.